Moving into the next section entitled Hardening Applications, here we're looking at particular services or particular roles that you're going to have running on generally a server, but occasionally you can have these on a workstation. Web servers, especially Microsoft's Internet Information System, IIS, can run either on a workstation or on a server. And as I said, I think IIS 4 and 5 actually had lockdown scripts. IIS 6 was certainly a lot more secure, and then IIS 7 is even more modular, and I think you'll see increasing levels of security with that. Unfortunately, I think most of the information that's in this section is actually kind of outdated. They talk about the iUser underscore computer name, and that has gone away in version 7 of the Internet server, at least in terms of Microsoft. I don't think a whole lot of people are using CGI scripts anymore. I would just caution you, make sure that you use some form of authentication. Don't use anonymous authentication unless it's on an intranet. And even if it is on an intranet, make sure that you do have another layer of security, such as IP address restrictions or time of day restrictions or that sort of thing. Web servers really are pretty vulnerable. Go through best practices. Make sure that anything that you've installed, that you actually know why it's there, what it provides for you. If you don't know what something is, research it. There's no harm in turning something off. You don't want to really do this on a production system, but turn it off one evening. Get a maintenance window, turn something off, and see what works and what doesn't work. Sometimes you have to do some trial and error to figure out what role something might be playing on your server. Email servers, such as Microsoft Exchange, are something that many installations run. And the very first thing they talk about is run a virus scanner so that anything that comes in, usually in the form of attachments, but it can be even in the body of an email, make sure that you scan those for any kind of malware or virus. I think we covered in the last chapter that many email servers will not accept attachments that have an executable file extension. That's actually a pretty good thing. I think I told you also that one workaround to that is whoever's sending an executable to you, have them rename it so that it'll get through your email system. And then once you get it on your end, go ahead and name it back to whatever it needs to be in order to execute. There is a real-world scenario here that says using access control lists to address spam. Maybe this is something that would be helpful, but I think that there's so much address spoofing that takes place that I don't know that actually trying to prevent a particular IP address from coming in is really going to be a good way to go. I think probably a more effective method of preventing spam is to subscribe to a blacklist organization, and when you get email from a particular domain, you'll take that domain and interrogate the blacklist to see, is this a known spam domain? And if it is, then you'll just reject it, and a non-delivery report will be sent back to whoever originated it. FTP servers. My best suggestion is let somebody else run your FTP servers. You can usually get an ISP, and I know I've got several network solutions accounts where I run FTP servers, and you can set up some basic security with usernames and passwords, but I would really try and separate any FTP access from the rest of your production system. There is a new version of FTP that came out from Microsoft that came out with Server 2008, and that version does allow secure FTP. FTP by itself is a really insecure protocol. It sends everything in clear text. And a lot of times people don't even secure FTP sites, they just have anonymous access that's open. I would suggest trying to use secure FTP, and they do have a little blurb in that at the end of the FTP section. Hardening your DNS server is an excellent thing to do. It's one of the most vulnerable parts of your organization because it's also an essential component. You have to have DNS at some point so that you can navigate out to the internet. It's pretty much a given that anybody who has an internet presence is going to have DNS servers behind there. The book mentions denial of service attacks, which we've covered. It mentions the fact that you can do footprinting, which means that you can query a DNS server, and depending on what kind of information you get back, you can get an idea of what devices might be behind that firewall and how they may be structured. You can also get DNS cache poisoning, where you have bogus records that are either part of your cache or they're part of your DNS database. And so you can have corruption either in the cache or in your physical database. There are several things you can do at the router level to prevent DNS attacks. And one of them is to make sure that DNS runs on port 53, so you make sure that you limit port 53 traffic, generally to one server or to a handful of servers, and then you don't really let any incoming traffic come back in unless it was generated on the inside part of the firewall. There is a short section here on the Network News Transfer Protocol, and I don't really know anybody who runs those servers. I know some people subscribe to those, but not that they run them. These deal with news groups, so that is the primary user group that NNTP servers will service. Moving on to file and print servers and services. We talked about hardening the file system itself, but when you are accessing files and communicating across a network, there is a set of TCP ports that are going to be used for that, and that depends on your operating system. If you're using a Microsoft operating system and a Microsoft file system, the book tells you that a lot of the communication can take place through remote procedure calls, and it uses the NetBIOS protocol to do that. And in particular, ports 135, 137, 138, and 139 are particularly vulnerable. If you're not using NetBIOS, that's a good thing. You can use server messaging blocks, SMB, and those tend to use port 445, and so you don't have those lower level numbers that are open. They do have, I think, a really good suggestion here. It says directory sharing should be limited and do everything you can not to share at the root. Their suggestion is to even create a subfolder off of the root and then share at that point so that you've still got something that is not at the root. You're one step removed from that. And I think that's a really good idea. You can also use a combination of share and NTFS permissions in a Microsoft environment to make sure that you've got a distinction between locally accessed, meaning you are at the box or at the server, and then access across the network, which would involve the NTFS permissions as well as the share level permissions. DHCP is another way that your system can be compromised, and there's actually a couple different ways that DHCP can be exploited. Number one is if somebody gets into your DHCP database, the information that is sent out, instead of directing them to your real DNS server, if somebody plants bad IP addressing information in there, they can direct you to a different DNS server and then hijack your session or do all sorts of different things. In Microsoft land, what you want to do is make sure that your DHCP servers are authorized, and so when they come up, they actually authenticate into your directory services database, and so you've got a reasonable certainty that a DHCP server is legitimate. Another issue with DHCP is that it is very often integrated very tightly with DNS, and so when DHCP hands out an IP address, it's going to take that record and pass that off to the DNS service and insert either an A record or a PTR record or both of them. If you're using Active Directory, you can make sure that your DHCP server presents credentials to the DNS server so that, again, you've got a level of authentication for any record changes that are going to be made. There are also some best practices with DHCP servers. They tell you don't run a DHCP server on a domain controller just because you want to keep that Active Directory database separate from your DHCP server. Obviously, you can't separate DNS from a domain controller because you have to have at least one DNS server supporting your domain controller. The last section deals with what they entitle data repositories. These are going to be collections of information. I think the most common collection that we can talk about here as a repository is the Active Directory database. That is your directory of users, computers. You can have printers in there. You can have organizational units. It has the whole gamut of the organizational structure of your enterprise. You obviously want to make sure that number one, isn't corrupted and also is not stolen or somehow compromised. You can also take your Active Directory database, or in the case of Novell, you can have your eDirectory database, and then you can serve different information out of that. Most Active Directory databases, if you're running Microsoft Exchange, have a subset of information that deals with email. And you can publish that information from Active Directory over to your Exchange server. It's not obviously the whole database because you only care about mailboxes. You don't care about printers or that sort of thing, or organizational units in your Exchange environment. They talk about LDAP, which is the Lightweight Directory Access Protocol, and this is a way that you can make data available. You can either publish it through LDAP or you can make it respond to queries. If somebody wants to interrogate for a distribution group, then you could have an LDAP server that could interrogate your Active Directory database and then return that information. The last section of the text deals with actual databases, and these are going to almost always be relational databases. If it's a very small system and not very sophisticated, it's probably going to be a flat file database. But when they talk about databases, one of the things that you want to try and do is separate some of the different activities. The data itself, very often you want to reside in one location. You want the process that may either query that data or change the data to be resident elsewhere, and then very often you'll have a third component that is the client side that's going to initiate these tasks. If you can separate those and also have authentication and security between them, you can have a user initiate a particular task, the command handler gets it, and then they actually perform that task, send it off to the database, and either do the get or the put, whatever it is you need to have. And so they talk about 1-tier, 2-tier, and 3-tier models, and what I just described is the 3-tier model. If you have two of those components on one server and the rest is isolated, that's a 2-tier component, and then when you've got everything on one server, then that's called a 1-tier. In a small environment, especially like in a small business server, you're not going to be able to have multiple servers. So you are going to have everything in one location. And that pretty much wraps up Chapter 5. I think this is one of the shorter chapters, and I think it also conceptually is one of the easiest ones. It's pretty easy to identify vulnerabilities. You may not know specifically what you need to do in order to plug those holes, but you've got enough of a basis here that you can go out and interrogate best practices or security strengthening or something like that, and you can get a lot of good guidelines for hardening both applications and operating systems.